Okay, so welcome back to Mrs. Sell's SOL Review booklet. Today we're going to talk about SOL 6.4, which is demonstrating multiple representation of multiplication and division of fractions. I have the hints and notes here. I want to go over that with you, and I want you to draw this with me because maybe this will be a review of what we did a couple months ago. When we talked about multiplication and division, there is a way that you can show the representation by drawing the actual fraction. So let's look at the first one. Model each fraction in one direction. The second fraction will be in the other direction. Do you remember we represented one fraction by coloring the columns, and then we colored the rows in a different color, and where they overlapped was the answer to the problem, because this problem says 1/4 of 2/5. So we're trying to find a portion of it. So what we're going to do is first you have to look which one represents the fourths and which one represents the fifths. So look at your columns and look at your rows. You're going to draw this. So I have 1/4. Well, it looks like the rows are in fourths. Would you agree? So this is 1/4 going across, correct? And then if I look going down, it looks like these going down are 1/5, correct? So these all must be a fifth. So that's the first thing you have to look for. So now they want to know what is 1/4 of 2/5. So I'm going to look right here at the denominator. That's a 4. So I want to figure out which one of these, either the columns or the rows, are in fourths. So we said that it was the rows. So how many rows am I going to shade? 1/4. How many rows am I going to shade? One row, 1/4. So what I'm going to do is I'm going to shade 1/4. Here's 1/4, 2/4, 3/4, 4/4. I'm going to shade 1/4. Okay, so shade 1/4. Now, the next fraction says 2/5. So look up here. It says model each fraction in one direction, the second fraction in the other direction, okay? I think my board is off a little bit. I keep covering up the words. All right, so now I'm going to shade in 2/5. So I'm going to look at the columns. They are in fifths. So I'm going to use a different color so that you can see that. So let me pick the blue, and I'm going to shade 2/5. All right, there's 1/5. Now 2/5. Okay, so I shaded in 1/4 in one direction, 2/5 in the other direction. And then what do they both share? Where do they overlap? Both of them. Right here, right? So if you solve the problem 1/4 times 2/5, you could cross cancel, and if you decided not to, you would get 2/20, which is equal to 1/10. Right. So look how many are shaded together. That means 1/4 of 2/5 is 2 out of 20. So 2 out of the 20 are going to be shaded together. So for the next one, it says division of fractions. So with this particular one here, division of fractions can be represented by looking at the number of pieces that fit into a whole. So if you look right here, how many holes do I have? You have 3. Here's 1, 2, and 3. 3 holes. Now, they are divided up. Each one hole is divided into thirds. How do I know that? Because the denominator is in thirds. So 1/3, 2/3, 3/3 right here. Does everybody see that? 1/3, 2/3, and 3/3. That makes one whole. I have 3. I'm going to take 3 and I'm going to divide them into 2/3. I want to know how many that is. And it gives you the answer, 4.5. Now, how did we get that? So what they want to do is shade in 2/3. Now watch very carefully. I'm going to try to do this with a highlighter. 2/3 is right there, correct? Okay, how many 2/3 is that? That's 1 2/3. All right, let's do another 2/3. I could shade this one and this one. That's a third and a third. That's 2/3, correct? So that's 2. All right. That's 3. Can I make another one? Yes. So I can make 4 2/3, and then there's going to be a half left, a half of the 2/3 because I only have 1. I need 2, correct? Now, could you do that the long way? Absolutely. But I wanted you to see what it would look like. So if you solve this the long way, 3 divided by 2/3. Remember, we never divide. We multiply by the reciprocal. And look what you get, 9/2. 2 goes into 9 4 times with 1 left over. See? So what exactly is that saying? I'm taking 3 pies and I'm going to divide them all into thirds. And each person gets 2/3 of the pie. How many people can get 2/3? 4.5 people. For number 1, which expression is represented by the model? Well, look at what you have going down. Look at the columns going down. You have 1, 2. So you have a half here and a half here. 1/2 plus 1/2 equals 2 halves, which equals 1 whole, right? Then you look going across. I have 3 rows, so that means they're in thirds. So they want to know which equation is this. So let's see, what's shaded? 1/2 is shaded because I can look all the way down. So that's 1/2 is shaded. And then I need to look across. So if I look across, I have 1/3 shaded. So the correct answer is B, 1/3 times 1/2, or 1/2 times 1/3. Number 2, look at the model. What expression could be represented by the model? Well, this represents 1 whole, and then this represents another whole. And then they are each, so that's 2, right? Here's 1, here's 2. So you have 2, and I'm dividing them in what? Halves. Because here's a half, and here's a half. Here's a half, here's a half. So take 2 and divide it in half. That was the equation, which was C. Number 3, we'll talk about it. Number 3, Kayla is making an art project with 3/4 inch strips of fabric. She has a strip of fabric that is 4 inches long. So the fabric is 4 inches long. How many pieces can she cut from her strip of fabric? So she's making an art project. I have 4 inches. Each project needs 3/4. So I'm taking 4 and I'm going to divide it by 3/4. So remember, when you divide, 4/1 times 4/3. So 16/3. How many projects can I make? 5. Number 4, this is a hole, and look at the model. So how many sides do I have altogether here? 6 sides. Okay, now look at the model. How many sides are shaded? So how many sides do we see that are shaded on 1? 2 out of 6 are shaded. It looks like 2/6, which is equal to 1/3. So 1/3 of the die is shaded. 1/3 times 2 of them would be C. Okay, see me if you have any questions.